Welcome to Azure Simplified. In this section, we are going to learn about how to design a data storage solution for relational data. Table of Contents 1. Database Scalability Solution. Use Hyperscale, Sharding, or always-on read replicas to handle growing workloads efficiently. 2. Database Availability Solution. Ensure high availability with built-in failover groups, or always-on availability groups. As the CTO of Tailwind Traders, you need a low-latency, high-availability database solution for relational data. Azure SQL Database is chosen due to its fully managed service features and high availability, particularly in the business-critical service tier. 2. Dynamic Scalability in Azure SQL Database. Azure SQL Database supports dynamic scalability, allowing changes in allocated resources, CPU, memory, storage, with minimal downtime. Scaling can be managed via the Azure portal without modifying existing infrastructure. 3. Key characteristics of dynamic scalability. Choose DTU or vCore models, and define the maximum amount of resources to assign to each database with a single database implementation. Use elastic database pools, and purchase resources for the group, and set minimum and maximum resource limits for the databases within the pool. Implement vertical or horizontal scaling. Vertical. Increase or decrease the compute size of an individual database, also called scaling up. Horizontal. Add or remove databases to adjust capacity or overall performance, also called scaling out. Apply horizontal scaling by using sharding to partition data or read scale-out provisioning. 4. Vertical scaling with SQL Elastic Database Pools. Elastic database pools allow databases to share resources efficiently, reducing costs while managing spikes in usage. Choosing between DTU and vCore models depends on business needs. Business scenario example. Vertical scaling with SQL Elastic Database Pools. Company, Global Fashion Hub, an online fashion retailer expanding internationally. Challenge, Global Fashion Hub operates in multiple countries, each requiring a separate SQL database for localized product catalogs, customer data, and transaction records. However, demand fluctuates. Peak sales during holiday seasons in different regions. High traffic spikes during flash sales and promotions. Unpredictable growth rates in new markets. Maintaining individual dedicated databases for each region would be costly and inefficient. Solution. Vertical scaling with SQL Elastic Database Pools. Elastic Database Pools, instead of assigning fixed resources to each database, Global Fashion Hub groups them in a shared resource pool. Automatic resource allocation. Databases with higher demand can temporarily use more resources, while others consume less, optimizing cost. Cost efficiency. The business pays for the pooled compute power rather than maintaining over-provisioned service for each country. Performance management. Vertical scaling ensures that during major sales events, compute power scales up without downtime. Example use case. Black Friday sales. The US and UK databases experience heavy traffic, so the pool dynamically allocates more CPU and memory. Post-sale period. Demand drops, and resources are automatically scaled down, reducing costs. New market entry. A database for a new country starts with minimal resources and scales up as demand grows. By leveraging SQL Elastic Database Pools with vertical scaling, Global Fashion Hub can efficiently manage its international operations while optimizing performance and costs. Horizontal scaling and its methods. Sharding. Partition data across a set of SQL databases that are identically structured. A set consists of a primary read-write replica and secondary read-only replicas. You can split large databases into smaller components to improve performance and make them easier to manage. Read scale-out. Read scale-out. Load balance read-only workloads for a set of SQL databases. Offload read-only workloads by using the compute capacity of a read-only replica, instead of running workloads on the read-write replica. Isolate some read-only workloads from the read-write workloads and not affect performance. Example of sharding. Partitioning data across SQL databases. Scenario. Imagine Ride Fast, a global ride-hailing service like Uber or Lyft, which manages millions of ride requests, driver details, and customer transactions across multiple cities and countries. Challenges without sharding. Single large database bottleneck. A central database storing all customer and ride data becomes slow and inefficient as the user base grows. Scalability issues. High read and write operations lead to performance degradation. Data isolation needs. Regulatory requirements may require storing customer data in specific geographic locations. Solution. Sharding the database. To handle the growing user base and ensure smooth operations, RideFast implements sharding by partitioning its data across multiple identically structured SQL databases. Sharding key selection. The system partitions data based on city or region, e.g., New York, London, Tokyo. Each city gets its own separate database, ensuring faster query performance and localized scalability. Primary and secondary replicas. Each shard, city-specific database, has a primary read-write replica that processes transactions. Secondary read-only replicas handle queries for reporting, analytics, and customer insights without affecting real-time operations. Load balancing and AMP, performance boost. If the New York shard receives heavy traffic, Write Fast can add more resources only to that shard, without affecting London or Tokyo. Read requests for trip histories are offloaded to secondary replicas, reducing stress on the primary database. Regulatory compliance. Some countries have strict data localization laws, e.g., the EU's GDPR. With sharding, Write Fast ensures that European user data stays within EU-based servers, meeting legal requirements. Summary. Choosing the right scalability solution. Organizations should select a database scaling strategy based on specific scenarios. Managing multiple databases with unpredictable demand, elastic database pools and AMP, vertical scaling. Ensures dynamic resource allocation within a predictable budget. No per database charge. Costs depend on peak resource usage. Compliance with geographic data regulations, horizontal scaling and AMP, sharding. Data is partitioned across multiple databases in different locations. A shard map manager maintains connections to the correct database based on location. Supporting business intelligence and AMP, data integration, elastic database tools and AMP, elastic query. Allows querying across multiple databases using TSQL. Integrates with Excel, Power BI, and Tableau for data visualization and analysis. Each solution optimizes scalability, performance, and cost based on the business needs. 1. High availability in Azure SQL, vCore model. Azure SQL offers three main service tiers in the vCore-based purchasing model. 1. General Purpose Tier 1. Uses a remote storage-based architecture with Azure Premium Storage. 2. Best for cost-effective workloads with moderate performance needs. 3. Availability, 99.99%, SLA, with automatic failover. 2. Business Critical Tier 1. Uses a high-performance architecture with local SSD storage and always-on availability groups, AOAGs. 2. Best for mission-critical applications needing low latency and high availability. 3. Availability, 99.995%, SLA, with automatic failover. Hyperscale Tier 1. Uses a log service and distributed storage architecture. 2. Best for large-scale databases needing rapid auto-scaling, up to 100 terabytes. 3. Availability, similar to general purpose but optimized for massive data growth. Example. General purpose availability in action. Scenario. E-commerce web application. A small to medium e-commerce company wants to host its online store database on Azure SQL. The database needs high availability but should remain cost-effective since the company has limited IT resources. Why choose general purpose? 99.99% availability ensures the database is always accessible. Lower cost than business critical tier, making it budget-friendly. Azure Premium Storage keeps data safe even if a compute failure occurs. Automatic failover ensures minimal downtime. How general purpose ensures availability in this case? Day-to-day operations. The application connects to Azure SQL via a gateway. SQL queries for products, orders, and customers run on the primary compute node. Data and logs are stored in Azure Premium Storage. If a compute failure happens, Azure automatically provisions a new compute node. The new node reattaches the existing storage, data remains intact. The application reconnects with minimal downtime. Backups and disaster recovery. Automated backups allow the company to restore the database if needed. Geo-replication can be enabled for additional protection. Example. Business critical availability in action. Scenario. Online stock trading platform. A financial services company runs a real-time stock trading application where latency, availability, and failover speed are critical. Any downtime or slow response time could result in millions of dollars in losses. Why choose business critical? 99.995% availability ensures no downtime. Always on availability groups, AOAGs, enable instant failover to a secondary replica. Local SSD storage provides ultra-fast query performance. Red scale-out offloads reporting and analytics to a secondary replica. Day-to-day operations, traders place orders via a web or mobile app. The primary replica processes buy, sell transactions in real time. 3 secondary replicas are kept in sync and ready for failover. 1 secondary replica is used for real-time analytics, allowing market trend reports without impacting primary database performance. If the primary replica fails, failover happens instantly, one of the secondary replicas becomes the new primary. There is no need to create a new node, unlike general purpose. Traders continue trading seamlessly with minimal downtime, seconds. Performance optimization, low latency queries ensure stock prices update in milliseconds. Automated backups protect transaction history. Geo-replication can be added for disaster recovery in another region. Example, Hyperscale availability in action. Scenario, global video streaming platform. A video streaming company, like Netflix or YouTube, needs a highly scalable database to store millions of user preferences, watch history, and recommendations. The database should handle sudden traffic spikes, support real-time analytics, and ensure minimal downtime. Why choose Hyperscale? Massive storage, 100 terabytes plus, to store vast amounts of user data. Fast scaling to handle peak traffic, e.g., new episode releases. Red scale out for real-time recommendations and analytics. Fast failover ensures the app remains available even if a compute node fails. How Hyperscale ensures availability in this case? Normal operations, handling millions of users, the app queries user preferences, watch history, and trending videos from the Hyperscale database. Multiple compute nodes process queries in parallel for fast response times. Read replicas handle recommendation engine queries without affecting the primary database. If a compute node fails, Azure automatically switches to another compute node instantly. No data loss, since storage is separate from compute. Users continue streaming without interruption. Scaling during peak traffic, new movie release, Hyperscale instantly scales up compute nodes to handle increased queries. Storage grows dynamically without requiring downtime or migration. The platform remains highly available even under extreme loads. Summary: choosing the right database availability tier. When selecting a database availability tier, consider performance, scalability, and failover needs, general purpose, standard, basic in DTU model, best for balanced compute and storage, suitable for most business workloads. Business critical, premium in DTU model, ideal for low latency, high availability applications, with strong failure resilience. Hyperscale, no DTU equivalent, designed for large-scale storage and read-heavy workloads, offering fast scaling and multiple read replicas. Thanks for watching. Don't forget to like, share, and subscribe. Drop a comment with your feedback.